Hello everybody, I'm Adam. In this problem, we have our point given in rectangular coordinates as negative root 3, negative root 3, and we want to convert that point into polar coordinates. So in converting, we want to take our point with coordinates x and y, and we want to convert that into polar form with coordinates, say, r and theta. And how can we do that? Well, we know that we have some conversion equations to help us. Namely, one is, say, that tangent of theta is equal to, say, y over x, and that r squared is equal to, say, x squared plus y squared. So let's start by looking at tangent of theta equals y over x, and see if we can use that to help us find what theta is equal to. So if tangent of theta is equal to y over x, wanting to solve for theta, actually this implies that theta is equal to, right, tangent inverse of y over x. So that's what we can use. So theta being tangent inverse of y over x, so theta, right, is going to be tangent inverse of our y over our x. Now that's the coordinates of our point, which we have as both negative root 3. So negative root 3 over negative root 3. Well, negative root 3 divided by negative root 3 just gives us a positive 1. And so tangent inverse of 1 tells us that theta is going to be equal to pi over 4. Okay? Now, before we take a look at this, one thing that we have to keep in mind is the range of tangent inverse function is from negative pi over 2 to positive pi over 2. So the value of theta you're going to get is only going to be between there. It doesn't automatically mean that this value of theta is the one that we want. And what do I mean by that? Well, if we keep in mind where the point negative root 3 is, if we consider x is negative root 3, y is negative root 3. The point in rectangular form sits right here. And so our angle pi over 4, the angle pi over 4 has us going in that direction. So it might be the right angle, or we might want to find something else. That's where we're going to find what r is and see what we can do to match the two to get a point that will get us exactly in that spot. So let's look at r, and then we'll come back to this theta equals pi over 4. So for r, so r squared is equal to x squared plus y squared, or r squared is equal to our x, negative root 3 squared plus y squared, or negative root 3 squared. So that's just equal to squaring both. We have 3 plus 3, or equal to 6. So then r, taking the square root of both sides, r is equal to positive or negative, say, square root of 6. Okay? So with this, what can we do? Well, going back with theta equal pi over 4, so if we have the angle pi over 4 pointing us in that direction, if we went negative root 6, negative meanings r being a directed distance, we go root 6 distance in the opposite direction, that would get us to that point. So it looks like one version of the polar form of the point, since polar coordinates are non-unique, would be r is negative root 6, and theta is, say, pi over 4. So that's one of them. So we could go home and say we're done, but we have another value of r. Let's just see if we can use that. So r being positive root 6, so positive means going in the direction of whatever angle we are. So first what we need is an angle that's going to point us in the direction of that point, so we can go a distance of positive root 6. Well, if we start with theta equal pi over 4, we know we can just add pi if we need to. So adding pi would get us over here to theta being 5 pi over 4. So that would be the other point we could have. So the other point, right, angle 5 pi over 4, and r positive root 6. So there's another polar form of our point. So either one will work. There we go. Thank you very much.